All right, guys, we're going to get started with our e-learning lesson for today. We're going to be starting chapter 7 tomorrow, and actually we're starting it today. Chapter 7 is all about angles and triangles and quadrilaterals and other shapes. And so it's our last chapter that we have this year. And so it starts off and we're going to review some angles you guys already know. But on today's e-learning lesson, I'm going to introduce you to a lot of the vocab. So a lot of the different angle types and how to determine what kind of angle it is. And then your homework is going to be really, you don't have any homework just to watch this video. You just need to watch this video, and then you're going to be scored on, did you watch the video and how accurately did you respond to the questions from today's Edpuzzle video. So let's go ahead and get started. Remember that you can rewind the video at any time if you miss something before you even get to one of the first questions. Okay? So we have 4 different types of angles that you guys should be familiar with. We have acute angles, which are less than 90 degrees. We have right angles, which are exactly 90 degrees. We have obtuse angles that are more than 90 degrees, but less than 180. And then we have straight angles, which are exactly 180 degrees. So straight angles are basically just lines. So every line measures 180 degrees. Okay, we should be familiar with that. And so this first question says, what is the measure of the angle formed by the hands at the clock at the given time? And so I know at 9 o'clock, the hour hand is pointing at right at the 9, and the minute hand is actually pointing up at the 12, right at, actually it's a little bit longer. Minute hand's longer than the hour hand. So it should look like this. And so what kind of angle does that make? Yeah, it makes a right angle, right? We know that's exactly 90 degrees. Okay, looks just like this angle here with it being straight up and down. And not that right angles always have to go straight up and down and horizontal and vertical, but they do have to meet at 90 degrees. It's obvious that these two, these hour hands and minute hands meet at 90 degrees here. For the next one, 6 o'clock. 6 o'clock is going to be having the hour hand point straight down. And the minute hand is going to be pointing straight up at the 12. And so that would be a 180 degree straight angle. It's going to be a straight angle. 10 o'clock. 10 o'clock would have the hour hand pointing at the 10 and the minute hand pointing at the 12. And so at that point in time, we don't have a right angle. We have something smaller than a right angle. And any angle that's smaller than a right angle is a cute little angle, right? An acute angle is less than 90 degrees, right? We know that looks something like that. And then 3:45, this is an interesting one. Well, you'd think that at 3:45, the hour hand would be pointing at the 3, and the minute hand, we know 45 minutes is 3/4 the way around the clock, so it's going to be here at pointing at the 9. And so that looks like a straight angle. However, the hour hand, if we're almost to 4 o'clock here, we're 15 minutes away from 4 o'clock, the hour hand isn't going to be pointing at the 3. The hour hand is going to be almost pointing at the 4, somewhere between the 3 and 4, but closer to the 4 than it is to 3. So what we have here is not a straight angle at all. This angle right here is definitely more than a right angle, but not quite a straight angle. We would say that this is obtuse. And again, obtuse angles greater than 90 degrees. Our obtuse angle looks more like something like this, but it's still obtuse. Okay, still obtuse. Some angles, like angle A here in this diagram, can be named by a single letter. If this does not clearly identify the angle, you should use 3 letters. If one letter does not identify the angle you're referring to, you should use 3, and make sure you're using capital letters when you do angles. In fact, big ideas when you do the problems tomorrow are going to ask you to use capital letters on your keyboard. Okay, so here's what that means. When I say angle A, everybody knows I'm talking about this angle right here, which happens to be a right angle. Okay, everybody knows which angle we're referring to. But if I say angle B is really could be this right angle. It could be this acute angle. It could be this acute angle. It could be this right angle here, or it could be this straight angle right there from here to here. I really don't know which angle I'm referring to. And so that's where the 3 letters comes in. You can see that angle D is the same way. Angle D could be referring to this right angle, or it could be referring to either one of these acute angles. So what they do is they use 3 letters here. So when we say angle BDE, that means starting at B, going to D, and then going to E. So that has to be this angle here. There's angle BDE, right? If I was referring to the other angle opposite from that one, I would say BDC, and that would be that angle right there, angle BDC. That little L looking shape, that is an angle symbol, which shows you I'm referring to an angle and not just 3 letters of the alphabet, or even a triangle, for example, which also uses 3 letters. Okay, so just so you know, if I wanted to say angle BDC, we know I'm talking about this angle here, or I could say angle CDB. C to D to B is still referring to the same angle. So you can reverse the order around. What you can't do is you can't be referring about this angle and have a B or a C in the middle. The letter that's in the middle has to be your vertex. And so in this angle, angle D is our vertex. So D has to be in the middle. If I say, for example, if I switch the letters around and say BCD, BCD is now referring to this angle. It's a completely different angle. So be careful that the way you order them, you can do frontwards or backwards, but you have to make sure the vertex is that middle letter. Okay. So let's move on to our first 4 questions here. It says, use the figure above to name each type of angle. I'm looking for a right angle. Okay, well, obviously angle A is the obvious right angle there. Let's be a little bit more, I don't know, let's think a little bit more deeply about it than this. I could say this angle here is a right angle, but how would I say that angle? I can't just say angle E. So maybe we should say angle FEB. Angle FEB. Or you could flip it around and say angle BEF would be the same angle. There are other right angles. You could say angle C up here, or angle BCD, DCB, however you want to say it. Obviously right angle here, here, this is a right angle, that's a right angle, these combined make a right angle, this is a right angle. A lot of different answers I could say. That's why it said name a right angle. There's more than one. For B, we're going to do an acute angle. So let me erase all my marks here. An acute angle. Well, I could say this angle, this angle, this angle, or that angle. And so let's not use the one that's already done. Let's not use angle BDE. Let's maybe use this one up here. Let's use this angle. Oops, let me get rid of my markings. Let's use this angle right here. And so I could say EBD. Angle EBD. Or you could flip it around and say DBE and still referring to the same angle. An obtuse angle. An obtuse angle, well, we have one of those right here. And so I could say angle ABD. ABD would be that angle, obtuse angle. ABD. Or flip it around and say DBA. Finally, a straight angle. Let's just use the one on the bottom here. FED. Angle FED. FED. That is a straight angle. Remember, straight angles are just lines. Okay. So there's an example of each of those. Next question. How many angles are formed by the intersecting roads? What do you notice about the angles? Well, let's see. How many angles are formed? 1, 2, 3, 4. 4 angles. Let's number them 1, 2, 3, 4. That might be easier. 1, 2, 3, and 4. It says, what do you notice about the angles? Well, it looks like the top and bottom angles are both acute, and the angles on the left and right, 2 and 4, are both obtuse. More than that, though, Angle 1 looks like it's the exact same size as angle 3, just opening up above it instead of below. And angle 2, which is obtuse, looks like it's just about the same size as angle 4. And in fact, they are the same size. Okay, they are the same size. Now, we call angles that are next to each other, we call them adjacent. So there's your next vocab word, adjacent angles. Two angles are adjacent when they share a common side and have the same vertex. Two angles are adjacent when they share a common side and have the same vertex. So right here's our vertex. Angle 1 and angle 2 share a common side, but no space in between. Angle 2 has its own space. Angle 1 has its own space. So we would say angle 1 and angle 2 are adjacent. Okay, adjacent, it means next to. Okay, I would not say that angle 1 is adjacent from angle 3, because although angle 3 does share that same vertex, they don't share a common side. So they're not next to, like angle 1 and angle 2 are, or angle 1 and angle 4 would also be adjacent here. Okay. Think of adjacent being like two states that share the same border. There's no overlapping space in those states. They're just next to each other. They share that, they have to share that same border to be adjacent. Okay. So name two pairs of adjacent angles from this figure. Two pairs of adjacent angles. Okay, well, let's look at the first pair here. Adjacent just means next to. So I could say that this angle here is next to this angle here. Those two angles. They share a common vertex and they share this same side right there. So how do I say it? Well, I could say angle FBA and FBA is adjacent to angle, let's see, FBA and then ABC. So angle ABC. Those two angles are adjacent. There's more. In fact, we could even continue using angle FBA, this angle here, and it's also adjacent to this angle, this one here, which is angle FBE, angle FBE, or EBF, however you want to say it. Okay, so they are adjacent. Let's look at this next figure and do two more pairs of adjacent angles. Again, adjacent means next to. They share the same border. All of them share this vertex J. Let's just do this one here. Angle QJK. And which angle do you think it would be adjacent to? Well, it's adjacent to two different angles. Okay, it's adjacent to angle QJP or KJL. But let's just say QJP. Okay, so those two angles are adjacent from each other. Let's look at two more. Let's look at angle, let's clear my writing here. Let's look at angle PJN, angle PJN. Okay, which of the following angles do you think angle PJN is adjacent to? If you said angle NJM, you would be correct. Also MJN, same angle, but they are adjacent. So angle NJM. They are adjacent angles. Again, adjacent just means that they are next to. Here's your second vocab word, vertical angles. Vertical angles are two angles that are vertical when they are opposite angles. Two angles are vertical angles when they are opposite angles formed by the intersection of two lines. Now remember, when we looked at the lines up here, we saw that there was adjacent angles. 1 and 4, 1 and 2 are both adjacent. 3 and 2, 3 and 4 are both adjacent. But remember we said that these two angles here looked like they were the same size. Same with the top and bottom angles. That is true. And those are called vertical angles. Vertical angles open up opposite from one another. So 2 and 4 are vertical, and 1 and 3 are vertical. And in this sense, the word vertical doesn't mean straight up and down like we normally think of two lines that are vertical. The word vertical means that they open up in opposite directions. Okay. So vertical angles are congruent, meaning they have equal measure. The word congruent means equal size. Okay. The reason we don't say equal is because in geometry back in, well, a long time ago when the ancient Greeks and Romans were the ones that were discovering all these geometrical things, they didn't have a word like we do for equal. They didn't have a word that meant that two objects were the same. They knew that two numbers could be the same. So they would say a number could equal another number. But they didn't have a word for two angles or two lines or two buildings to be the exact same. So they would say congruent, which means they have the same size, same shape, same measures, equal measures. And so that's congruent. Just think of that as meaning equal. Okay, we're going to name two pairs of vertical angles. So vertical angles open up opposite from one another. How about starting with this angle? What angle opens up opposite from this angle? That's also the same size. Remember, vertical angles are the same size. So how about that one right there? So angle FBA and angle DBC. These two angles here are vertical and they're also the same size. Okay, vertical and the same size. All right, the lights are back on. Let's keep going. Okay, so I have to find another pair other than these two pairs that are vertical. So let's maybe do this angle here, angle ABC, the big one. That's obviously an obtuse angle. And what angle would it be vertical from? Well, it's not this one, and it's not that one, and it's not that one, because those are too small. Remember, vertical angles have the same size. So they have to be exact same. This one also has to be obtuse. Okay, whoops, trying to erase this. So if this is the angle that I'm looking at, okay, what if I looked at this angle here? That one's kind of hard to see, but do you see that those two angles are the exact same size? Okay, again, that was a difficult one to see. I get that. ABC is vertical from FBD. So angle FBD. Okay. All right, so let's look at the other picture we have. Name two more pairs of vertical angles. Let's look at maybe this angle here, angle PJQ. Angle PJQ is this angle here. And we want to know what angle would be vertical from this angle. So what do you think? Well, if you were thinking this angle here, this time you're right. That is the correct angle. Angle MJL. Angle MJL. They are adjacent angles. Okay. Okay, so I have to find another pair. So this time let's do this angle here. Angle PJN. Angle PJN. Okay, and we want to know, hey, come back later. we want to know what angle would be congruent, or well, congruent, and then also opens up opposite direction. So go ahead and take a moment and answer the question. Okay, did you say angle KJL? Because that is the right answer. Angle KJL opens up the exact opposite direction and they're the same size. You could also say KJL or LJK, however you want to, as long as J's in the middle, you're okay with there. And so that would be a vertical angle. Okay. Okay, so that's as far as we're going to get in our notes today. We'll finish the rest of them tomorrow. However, I am going to do a couple things. I'm going to show you tomorrow how to find missing angle measures, knowing whether the angles are adjacent or if they are vertical angles. But you're also going to have to identify whether they're adjacent or vertical. So the last few questions we have in our Ed Puzzle video today, I need you to tell me what kind of angles these are. Are they adjacent angles or are they vertical angles? Okay. So I'll give you a hint on A here. They're opening opposite from each other. Okay. They look to be the same size. And so what angles do you think they are? They are, as you probably guessed, vertical angles. Okay. Nice job. If you said vertical angles, that is correct. Okay. B, angle B here, letter B. We have two angles that are forming a larger angle. And so do you think these are adjacent or vertical angles? Well, if you said adjacent angles, then you are correct. They are adjacent angles. And again, tomorrow, I'm going to show you how to find what the value of X is. So here's a question then. These two angles, obviously they're adjacent. They share this side right here. Okay. Form a larger angle. Okay, you can see the larger angle right here. What kind of angle is it? Is it an acute angle, a right angle, an obtuse angle, or a straight angle? Again, I'm referring to this angle right here, the larger angle formed by both angles combined. Is it acute, right, obtuse, or straight? Well, if you said it was a right angle, you are correct. This is a right angle. You can tell because they use the little right angle box right there. Okay. Let's look at C. So now that we have those examples, I want you to tell me, for example, C, do you think C is a pair of vertical angles or a pair of adjacent angles? We're referring to this angle and this angle. Are they vertical or are they adjacent? If you said that they're adjacent angles, you are correct. These two angles are adjacent. They share a common side and a common vertex right there. Okay. What about example D? Are these two angles formed by this right angle here and this angle here, are they adjacent angles or vertical angles? What do you think? If you said that they're vertical angles, you are correct. They are vertical angles. They're opening up in opposite directions. One's opening up to the top right, the other opening up opposite direction to the bottom left. They are also, since they're vertical, going to be the same size. And that means that that angle down there will be 90 degrees. And we'll talk about that tomorrow. All right, see you guys later.